Ready, sir? Thank you. So again, we want to look at sine rule today, and this introduction is actually clear. I believe so those who have been writing it, probably reading it as you're writing. I want to start with what we call solving triangle. We always solve what? That we know. What do we normally solve? Speak louder.
Area.
Do you solve area? What do we normally solve? That we are what? Solve height? What does that even mean? You guys lack some mathematical vocabulary. Yes, Matthew? What do we normally solve? This is something trivial, something common in maths. I don't know why it's difficult to say. Yes? Did you hear him?
Yeah.
Did you hear what he said? What did he say? What? The unknown. Oh, okay. That's still not what I want. Yes? You see, that means you're thinking about this topic. I'm saying, what do you normally solve in math? I don't understand. We solve the height. What do you normally? Look at that word, normally. I never said, what did you solve last time? What do you normally solve in maths? Yes? We normally solve equation. Come on. Think. What do you normally solve in maths? We normally solve equation. Oh, we solve the area. We solve the area. You find the area. You don't solve the area. We solve the height. You find the height by solving an equation that will lead to the height. You don't solve the height. You don't solve the area. Understand? We solve an equation. And when you solve an equation, you are finding the unknown. Somebody said, solve unknown. We don't solve unknown. We find the unknown when you solve the equation. You don't say we solve the unknown. No. The entire system is the equation. You solve that system, and the result you get is the value of the unknown. You are finding the unknown. You are not solving the unknown. You can say, I solve for the unknown. Am I making sense? So also, we can talk about solving triangle. To solve a triangle is just to find unknown again. What are the unknowns in a triangle? It could be the side. It could be the angle. I expect response, please. Please don't come bench warming today. You know what I mean by bench warm? Just sit down, no talk. No, we don't want bench warmers in our class here. In Form 3. You speak. Part of it is you talk. Okay? Now, how many sides and angles do we have in the triangle? Everybody?
3.
3 of each. So 6 altogether. Out of these 6, maximum 3 will be missing. And those maximum 3 can never be the angles. Or no, can never be all the sides. That's the only but. So, you can have this. I can have an enlargement of the same shape, and the angles will still remain the same. Okay? So there is no way I'll give you a question like 30, 40, no, maybe 40 here, 110. And this will be 30, 40, 20, 110, and 40. And the sides will be exactly the same thing. That's not possible. So if all the angles are the same, there are infinitely many triangles. It's just enlargements. So that is the only thing you can never be given. You can never be given all the sides and be asked to find all the angles. That's not possible. But every other possibility is there. You can have all the sides. If you have all the sides, you can be asked to find all the angles. You can have 2 sides and 1 angle, and you find the remaining 3 missing stuff. You can have 2 angles and 1 side, and you find the 3 remaining missing stuff. When you find them, you have solved the triangle completely. To solve the triangle completely means to find every missing item. Okay? But if you are just finding side, like the Pythagoras theorem, when you find h, what you are doing is to solve the triangle, but not completely. Because you are just solving partly. You get what I mean? Solving the triangle is to find the unknown. It could be the side, it could be the angle, the specified unknown. Okay? When I was in secondary school in Nigeria, we often get questions like solve the triangle completely. So they give us 3 of the parameters. They say find the other 3. So they are not going to say find the other 3. They just say solve the triangle completely. So which means find all the other 3 that is missing among this 6 stuff. Understand? So when you find missing side or angle, you're actually solving the triangle. And you will agree with me that you have been solving triangle in the past. Right? You'll be finding angles and sides in the past. So you actually been solving triangle unknown to you. These are some of the methods you have been using. Are you familiar with number 1? What is that? All angle add up to? You've been using that since God knows when. Maybe P5 or P4. Understand? Some people maybe took P3. Right? Depending on when you start this angle stuff in the primary. So this is primary. When you get to middle school, you were taught Pythagoras theorem. Yes? C squared equals A squared plus B squared. You use that to find unknown side. Pythagoras theorem has nothing to do with angle. And this has nothing to do with side. You can only use this if you have 2 angles, you are looking for the 3rd angle. Is that not? And there is no condition. As long as it's a triangle and you have 2, you can use this guy to find the 3rd one. Is that not? But this guy has a condition. What condition? Speak louder. Triangle. Must be a right angle triangle. What is that condition? You must know what? You must know. If you know all the sides, Lason, why do you need Pythagoras theorem? Okay? You must know what? You must know 2 sides. And Pythagoras theorem can help you find the 3rd one. And it must be right angle. Must this be right angle to be used? No. Could be any angle. But this must be right angle. So you learn this from primary. You learn this in middle school. And in Form 3, I introduce this to you. This must be what kind of triangle? This must be right angle. And you can use this. This is like a combination of the 2. You can use it to find both the side and the angle. Is that not? This is only angle for any triangle. This is only side for right angle triangle. Now this is right angle also, but you can use it to find both side and angle. That means there are still limitations. It means if my problem is not right angle, and I want to find the angle, and this guy cannot help me, maybe I only have 1 angle, or maybe I don't even have any of the angles. Maybe I only have the sides, I don't have any of the angle. It means I can't use this to find my angle. And these 2 will become useless because it's not right angle triangle. Then what do? That's where we have 2 different ideas that we'll introduce to you again. The sine rule and the cosine rule. That's why I said, while one can be used for all type of triangle, please note that 2 and 3 are only used. Please note that 2 and 3 are only used, thank you, for right angled triangles, to find sides and angles, of course. Okay, just everything we have just said. If we need to find side or angle of non-right angle triangle, what do? Because these guys will fail. Unless you already know 2 angles, then you can always use this one, right? But if that's not the case, you have to find another way. And that is one thing about evolution. Even the evolution of number is as a result of, oh, what we're using was not working. What then do we do? Then something else evolved. Something else evolved. In the past, people don't travel from countries, continent to another. People stay within where they are. They don't even know the other people exist. Okay? It's like the, is it the cave age or whatever they call it? when the man was living in the cave.
Ice Age.
Ice Age, thank you. That's what I was looking for. When the man was living in the cave, you don't even know there's another human, another place. Okay? But as time goes on, things naturally evolve. Then there is need for me to travel, and the distance is too far. What do? People start working on maybe the donkeys, right? Right? The carts and the horse, depending on the distance, and even that will not be enough, right? Then cars came on board at some point. I don't know, maybe the ship came before the cars. I think the ship came before the cars. But the ship can only be on water. Does that mean if I want to travel from here to Hong Kong by the bridge and there's no water, I push my canoe on the road? Then the cars must have been invented as a result of that problem. Am I making sense? Then even the cars have limitation. I'm not going to drive from here to Nigeria. Even if I just have to step on the accelerator all the way, I'm going to get tired. And of course, there was no driverless Tesla back then. But I could just say, Tesla, please take me to my mom's house in Abeokuta. And I just sleep. And he said, okay, your mom's house, you'll be arriving in the next 3 months. Enjoy the ride with all the food in the car, something like that. That would be so weird. How can I sit down for 3 months because I need to see my mom? Then people came up with the idea of the plane. And trust me, we have not seen the worst, trust me. Hyperloop is being invented now. Hyperloop is being invented now. Do you know what Hyperloop is? It's an underground system. It's as fast as crazy. Of course, you have seen magnetic trains in China. Because of course, everybody's beefing China with that, I know. Very fast. A journey that will take you 9 hours. Magnetic train will probably take you, I don't know, 1 hour or 30 minutes. Just like magnetic, as the name implies. It's like there's a force on the other end that's attracting that object and it's going to come so fast. Crazy technology. And then there's Hyperloop now. You don't need to get stuck. You just stay in the tube, and before you know it, it's like that. It's not a roller. It's not called a roller coaster. Have you had this? There's a ride in Galaxy. There's a resort in Galaxy. The red, green, and I don't know what that thing is called.
It's like a slide.
It's like a ride. You go inside the tunnel, like a cave. I did it in during the last break. Yeah, I know. It's crazy. My wife was scared, but I did it anyway. That you have to like slide through. They can see you sometimes when you use the easy one. But when I used the moderate and the very fast one, she couldn't see me until I came out. But I'm sure she was praying, oh my God, keep my husband alive. Just kidding. Okay, Hyperloop is that fast. Just Google Hyperloop. It's already been introduced in I think in US. I think India is looking into it. I think maybe UAE is looking into it. It's been developed. So we don't have to get stuck in traffic because everybody keeps giving birth to babies. The population of the world keeps growing. The land mass may not be enough for all our cars anymore. And I'm not going to fly a plane because I'm going from here to Macau side. There has to be another way out. Maybe all our bridges are going to be too congested. And we go underground, people. They're looking into that now. My point is, based on the need of man, things evolve naturally. Okay? Man is smart enough to think, okay, now the initial solution is not enough for all these problems. What do we do next? And then one of this is Sine Rule. All these guys couldn't take care of all our problems anymore. There's need to have different ways to do it. Understand? So, one of them is Sine Rule, the other is cosine rule. Sine Rule is the only one we're going to talk about today. And again, the first few minutes of next class, you can still practice your Sine Rule. Then I introduce cosine rule. Then you can practice that over the weekend. Please try as much as possible to always complete your worksheet on time, so that we can move as fast as we want. Understand? Now, Sine Rule is very easy, but I need you to understand some notation. So this diagram is not complete. I intentionally did that. the angles are uppercase letters, capital letter. So please don't write sine A like sine small letter A. This is wrong. You see, this is how you write sine A. You don't write sine A like this. This is wrong. A is the side that is facing angle A. Small a is the side facing angle A. So if I complete my picture, this will be small c. This will be small what? And this will be small. Similarly. So this notation is for both sine and cosine rule, and generally actually in triangles. But we use it, we talk about it a lot. And the sine rule is easy. Sine A over A, sine B over B, sine C over C. The sine rule states that the ratio of a side and sine of the angle facing it is always constant. If you pick a side 10 and the angle is 30, 10 divided by sine 30, you get 20, for example. If you do the same for B and for C, you're going to continue getting the same 20. And it doesn't matter which one, how you flip it. So you might see your IGCSE textbook written like this. Your friends in another school, their textbook might be written as this. It's the same thing. And I'll show you what I mean by that. We can only take two at a time. Of course, you have never seen an equation with two equalities, right? There's no three sides to an equation. So basically, depending on the problem you have, you might need to combine A and B, A and C, or B and C at a particular time. So let's say, for example, my sine rule is x over sine x equals z over sine z. Maybe my friend decided to write sine x over x, sine z over z. Maybe my friend decided to write it. If I cross multiply, I get x sine z equals to z sine x. Yes? Mm-hmm. If my friend cross multiplies, isn't it the same?
Yes.
Can you see that? Mr. Tomash, are you a cameraman or not? We can't see this. Help us out. It's the same. Please keep your eye on that if you don't mind. Does it make sense? It's always going to be the same. So it doesn't matter how it looks. Whether here or here. This thing can actually be shown easily. Let me show you. Of course, you don't need to know how. You just need to remember A over sine A, B over sine B. And please don't state A over sine A all the time. Can you read what I wrote here? Any triangle. If the triangle is PQR, don't write A over sine A for me. I give you 0. Because I don't know what you mean by A over sine A. If I cannot see letter A in the diagram. Okay? So if the triangle is PQR, what will it be? PQR? P over sine P equals, speak fast and loud, equals, that's what we're saying. So don't go about writing A over sine A all the time. I had a clash with them in Form 5 this morning because of that. I wrote triangle XYZ. Somebody's telling me A over sine A. I said sine A over A. I said wrong. And they were wondering why it is wrong. Oh, that's the formula. I'm like, that's the formula? Go back to your notebook. What did I write before that formula? Then everybody write, oh, you said in triangle ABC. So now, did I give you triangle ABC? Or am I supposed to spell it out for you from 5? So please be careful, okay? Anyways, now, how can we show this? It's on those time. How can we show this? If I have a triangle, A, B, and C, we all know this is small c, small a, and small b, right? The area of this triangle can be found in 3 different ways by trigonometry. Area, if I use AB, it will be sine what? If I use half times AB, it will be sine what? Plus on? Sine C. Are you sure? Corinne, do you agree? You're not sure? Manuela? Not sure? Corinne? Matthew? Oscar? Jenny? Speak louder. Fast. Not sure, Anna? Okay, who's sure? Jody, can you tell us why?
Because the angle is in between the two sides.
The angle is between the two sides. Remember that. Area is half times the two sides multiply and the sine of the angle between them. So together, area is going to be half BC sine what? Louder and fast. A. Similarly, the same area can be found half AC sine what?
B.
Somebody says C again. Now, these three areas, what can you say about them? They are all it's the same triangle. You shouldn't get 4 here, 5 here, 6 here. You get the same answer. Right? I have only 3 men. If they are all going to be equal, then it makes sense for me to say half AB sine C is half BC, right? Sine A, half AC sine B. Yes? Yes. Half is common to all of them, so I can divide all through by half. If I divide all through by half, what do I get? AB sine C, BC sine A, AC sine B, right? Okay, I'm going to divide all through by ABC. Let's see what happens. If I divide by ABC, initially I have here AB sine C. I divide by ABC. BC sine A. I divide by ABC. AC sine B. I divide by ABC. Ladies and gentlemen, tell me what you notice. Yes? Sine C is equal to? Is equal to?
Sine B over B.
That's a simple way to prove the sine rule. Understand? So whenever we want to use sine rule, we only combine 2 of them. Maybe A and C, or A and B, or B and C, depending on the problem at hand. So I might have to give you an example tomorrow, but before I do that, I'm going to tell you when you use sine rule, because for cosine rule you have to be able to differentiate. Like I said, at any point in time, you only need to use 2, so let's focus on these 2. There are 4 variables involved. Capital A, small a, capital B, small b. It could be capital X, capital Y, small y. It could be Q and R. There are 4 of them involved. Okay? Among these 4, only 1 should be missing. Which means, for a particular group, they must be complete. So either the A group is complete and B is half attendance. You understand what I mean? What do I mean by A group is complete? Capital A is known, small a is known. Then maybe for the B, you know the angle, you don't know the side, or you know the side, you don't know the angle. Are you with me? So you're having a shape that will look like this, or that will look like this. So there will be one group that is complete. Is that not? You know the angle and the side. Again, there will be one group that is complete. So in the first instance, maybe you know this, but you don't know this. Or maybe you know this, but you don't know this. Do you agree? For you to have, among these 4, for you to have only 1 missing, you have these 2 possibilities. Which means in any case, you look at your triangle, you can notice this pattern. That there is a side and the angle facing it known. If your picture shows you is an angle and a side facing each other already given, your sine rule can be used. All you have to do is focus on the partly given one and state the appropriate sine rule. I like to call them family. There is a family completely in attendance, and there's a family that is partly attendance. Oh, parents came, the child did not come. Or the child came, the parent did not come. But there's a family that is complete. If you notice that, your sine rule can be used. And it must not be a right angle triangle. If it's a right angle triangle, you use sine rule, you're just wasting your time. Go to Pythagoras theorem and SOHCAHTOA. Sine rule should be used when these guys fail. Am I making sense? So I will not give you this worksheet. We will do the worksheets tomorrow. I'll give you an example first, then you can practice this worksheet maybe for the first 30 minutes we do that. Understand? Let's go, thank you. What do we have next? Bio, okay. Your bio, you go to the lab or teacher come here?
No, we go there.
Okay.
Other classes.
I'll write when to use the sine rule, okay? Then you can copy the note later. So once you can leave the video, I'll turn it off when I'm done writing.
Okay.
What? Bye.
Hello. Let's see if we capture the last part. Yes, we did.